In this example, we have an archer shooting at a tree. The tree is 50.0 feet away from the archer, and the archer aims the arrow horizontally. In other words, the angle is 0 degrees. As the arrow travels to the tree, it falls a total of 4.12 feet. And the question is, what's the initial speed at which the archer shot the arrow? Well, to solve this problem, we first have to figure out what we know. We know all of the things that are listed in the diagram, but we also know the acceleration in each dimension. After all, this is projectile motion. So the acceleration in the y dimension is the acceleration due to gravity, negative 32 feet per second squared. I use that value for the acceleration due to gravity because all of my dimensions are given in feet. The acceleration in the x dimension is 0 because nothing's pushing or pulling on the arrow in that dimension. Now we don't have a value for the velocity in each dimension, but we do know how it relates to the initial speed v0. After all, in the x dimension, the velocity is the magnitude, the speed, v0, times the cosine of the angle, and the angle we know, it's 0 degrees. Well, the cosine of 0 is 1, so in the x dimension, the velocity is simply v0. In the y dimension, the velocity is once again the magnitude, the speed, v0, times the sine of the angle. Well, the sine of 0 is 0, so there is no initial velocity in the y dimension. Let's go ahead and put these up with the things that we know. Okay, now how can we use these things we know to solve the problem? Well, v0, what we're trying to find, relates to the x dimension because that's the initial velocity in the x dimension. Remember the way these problems work. Usually we have to go to the other dimension first to solve for something, then we can use it in the dimension of interest. Well, since the dimension of interest in this case is the x dimension, that's where v0 is, let's look at what we can find in the y dimension. In the y dimension we know v0, we know acceleration, and we know the distance it traveled, 4.12 feet. So we can use equation 2.19. Delta x equals v0 t plus 1/2 at squared. Delta x is displacement. In the y dimension, the displacement is negative 4.12 feet. Remember, the arrow falls down 4.12 feet, and I defined down as negative because I gave the acceleration due to gravity a negative value. So the displacement is negative 4.12 feet. The initial velocity in this dimension is 0. We don't know the time. We do know the acceleration. It's negative 32 feet per second squared. And once again, we don't know the time. Now, the first term on the right-hand side of the equation drops out because 0 times t is 0. So we're just left with negative 4.12 feet equals 1/2 times negative 32 feet per second squared times t squared. Well, we can solve for t squared, and when we do that, we get t squared equals 2 times 4.12 feet divided by 32 feet per second squared. Feet cancel, and when I take the square root of both sides, I find that t equals 0.51 seconds. Okay, that's now something we know, so we can put it in the we know column. Now we can use that information to go to the x dimension and look at things there. In the x dimension, what do we know? Well, we were given the displacement in the x dimension. We also know the acceleration in the x dimension. And because we looked in the y dimension, we also know the time. So we know displacement, time, and acceleration. If we look at equation 2.19, that relates displacement, velocity, acceleration, and time. We know everything but velocity, so we can solve for it. The displacement as given is 50.0 feet. We don't know the velocity, but the time is 0.51 seconds. The acceleration is 0, and the time once again is 0.51 seconds. The second term on the right-hand side cancels because the acceleration is 0. So we're left with a pretty simple equation, and all we have to do is divide both sides by 0.51 seconds to solve for v0. When we work out the numbers, we find that v0 equals 98 feet per second. So that's the initial speed with which the arrow was launched. Okay, so once again, think about what we've done here. We took a two-dimensional problem and we split it up into two one-dimensional problems. We realized that our final answer was going to come from the x dimension, so we started in the y dimension. We used the y dimension to figure out time, something we needed to know for the x dimension, and then we went to the x dimension to solve the equation. That's the kind of thinking you're going to have to do to be able to solve problems like this.